Hi there, I'm Hao. This is just another video of me solving random number problem. So today we have combination sum. If given an array of distinct integer candidate and the target integer target, I'll return a list of all unique combination of the candidate where the chosen number is sum to the target. You may return the combination in any order. Uh, okay, and it has to be unique, right? So so if we have the candidate, so we can choose the number. Let's see. Uh, Okay, yeah, you can choose the number, the same number may be chosen from the candidate an unlimited number of time, right? So you can have 223, right? 223 is the same as 322, right? So we don't want any duplicate here. Okay, so you're gonna have four choices, right? The first choice is gonna be two. We have to pick one number, right, at a time. Three, uh, six, right, and then seven. Okay, our target is seven, right? Target is seven. So we keep track of our sum, right, in the current array. So two, because if we don't keep track of the sum, when we and in every recursion step, right, we need to calculate the sum in the array, and that is it's gonna be very slow. So we always keep track of the sum. I'm just not gonna show it here. Right, so every time you're gonna have four options, right? Two, 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 three, two, six, and then two, seven, right? One, two, one, two, three, four. Okay. So the sum now is nine, right? Which is more than our target now. So we just simply uh ignore, right, this path, right? So two and six are eight, right? So we found our first solution here. Sorry, our target is seven, not eight, my bad. So because eight is larger than the target, right? We just simply ignore this path, right? So we keep going, right? Two and three, two and two. We can do two, two, uh, two, 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 two is six, right? Still valid. And then two, two, three, right? Two, two, three is eight. So we found a solution here, seven, right? Right. So two, two, six, right, is larger than the target. So we're just gonna ignore this path, right? That's done, right? So at every iteration step, right, we need to iterate we need to iterate through the whole candidate array again, right? And try every single element because we can choose a candidate an unlimited number of times, right? And yeah, if the sum is larger, then we're just gonna return. Okay, so here the smallest number we can go is two, two, and then two, 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 and then six, right? Or two, right? The smallest number we can choose again is two. You give us the number eight, right? Which is larger than the target here, right? So we can just ignore this path. Okay, so you can go, you can continue from here, right? We're gonna have two paths, two, three, two, right? And then two, three, and three, right? So two, three, three is eight, right? Larger than seven, so you can just ignore this path. Okay, so we only have one path here, and we found another solution, right? Two and two is four plus three is seven. So we continue to here. So it is we can pick. We have to try it again, right? Three and two, three and two, right? Three and three, and then 3, 3, 6, and so 3 and 6 is 9, right? It's larger, so we just can just ignore. Right? And 3, 2, 2, 3, 2, 2. Right? It's 7, so we found another solution. And then 3, 2, 3. So that is larger, right? So we can just ignore. And then 3, 3, 2. Right? 6 and 8. So that is larger, so we can just ignore. Right? So we only have one path here. There's 3, 2, 2. And notice that it is a duplicate, right? It is a duplicate. So 3, 2, 2 is the same as yeah, 2, 3, 2 is a 2, 2, 3 is the same as 2, 3, 2, right? And also it's the same as 2, 2, 3. So as you can see here, we have three duplicate here, right? Even though it gives us the correct solution, but we have a minimum of so far like three duplicate here. So how can we avoid that, right? And this is another solution, right? So for 6, right, we're just gonna stop because like the smallest number we can go is 6 and 2, right? We just give it 8, which is larger than the target, right? So in the output we have two solutions, right? 7 and then 2 to 3. So like any of this, right? So how can we avoid the duplicate? So if we start from 2, right? If we start from 2, which means we already try all combination um between 2 and 3, right? 2, 3, 6, 2, 3, 6, 7, right? So when we are at 3, we don't need to go back, right? So let's say this is our candidate array, 6 and 7, 0, 1, 2, 3, right? So if we are starting from index uh 0, right? Because you can choose a number an infinite amount of time, right? Which means we already tried the combination between 2, 3, 6, and 7 here. So when we are at 3, right, we don't have to go back and try 2 again. We can just move forward, right? Right. So we can give each of them a start index, right? 0, 1, 2, 3. So you can only start from index 0 here, right? So same thing here. Right, you're gonna start from because we can choose the same number again, right? So we give it index of 0. If we go to the right, right, we can give it index 1, right? Same thing here, 0 and then 1, right? So it has to start from index 0, right? And here it has to start from index 1. Okay, so if it start from index 1, it has to try the number 3 first, right? Which is 2 to 3. So we have one solution here. So however, in this branch, right? Because we have to start from index 1 here, so it has to try the 3, right? Not the 2. So if we keep moving, right, we need to give it an index of 1 here, right? So the next number it has to try is 3, right? Not 2. We cannot go back to 2. So which means 8 is larger than 7, right? So we can just ignore this path. 2, 3, 3. Right? We can just ignore this path. Right, same thing over here. So it has to start from index 1 here, right? So 2 is no longer an option because we need to start to iterate. The option that we have gonna be from 3 to 7, right? From index 1 to 3, 1 to 3. So this is not an option, right? So we only have 3 and 3 here, right? And 3 and 3 and another number is 3. It's just already larger, so we just ignore this path, right? So if we keep going, it's gonna be 3, 3, and 3, right? And then 3, 3, 6, right? So on and so forth, right? And we're just gonna ignore this fact, right? It is index 1, this is index 2. So for 6, right? Same thing, right? Index 2, we need to start from index string. So the available candidate is 6 and 7. For 7, the available candidate is 7. Right. So the whole logic is that if we're starting from 0, right, we have all possible combination. Right? We're gonna have 2, 3, right, or 3, 2, 3, 2, right? Sorry, we're gonna have 2, 2, 3, right? So if, when we are at 3 here, right, we don't have to try 2 again. We have to just have to move forward because we already tried that combination when we are at 2. Okay, so let's call this up. So we need our backtracking function as usual. We take in the num, right, which is the decoder number that we are storing in our array, right? The sum. So we don't have to calculate it every time. And we need a star index. Combination array, and then we need to call the backtracking function starting at the empty array 0, 0. Then we can return a combination at the end. Okay, so we start from the star index gonna start from 0, right? So what is our base case is when sum is larger than the target, we can just return. So if the sum is equal to the target, right, we can add a combination, add the current array into our combination store. Okay. And then we need to try every single element, right? Starting from the star index. We need to try every single candidate, right? Starting from our star index. Okay. So we can push number, then call the backtracking function again on nums, right? Sum plus the candidate of I, and nums of top. Try the next one. Right. So we always start from the star index here, right? We are not allowed to go back. And in the star index that we so if we are starting from 3, right? So the star index has to be at least 3, right? 3, 4, and 5, right? And you cannot go back to 2 again. Okay. And it work. Submit. And so the time complexity would be because we have to try because we can pick a same number an unlimited amount number of times, right? We have n path, n path. There will be n right, to. So what is our recursion depth? So our recursion depth would be the target, right? So like the total number that add up to the target, right? So it would be around like the target divided by the minimum, the divided by the smallest candidate, right? Plus 1. Okay. So thank you for watching.